Good afternoon, my YouTube viewers. It's Crystal here, and what I'm doing this afternoon is I'm doing a code review. I'm doing a code review on the Traveling Salesman Problem. If you remember a couple of videos, I did a code review on hill climbing algorithm. Well, the hill climbing algorithm is actually used to solve the Traveling Salesman Problem. So I decided that I'd look into the Traveling Salesman Problem as well. So that's what we're going to do. I've got 3 scripts with the Traveling Salesman Problem, and we're going to go through all 3. And the reason why is because the Traveling Salesman Problem is a very common algorithm, so it's all over the internet. So what I'm doing is I'm just doing a code review rather than trying to write the code, because I'm under a lot of pressure. I have to do a lot of code reviews, a lot of study with me's, a lot of blog posts to try to get one out a day. So unfortunately, I don't have the time to sit and think about it like I should. So on this first code review that we're going to do, we got it from a YouTube video. And I suppose I could have done a study with me because I transcribed the code from the YouTube video to my notepad, and then I went over and did it, coded it in Google Colab, and it worked the first time. So if I had known it was going to work the first time, I could have done a study with me as well. So this is the YouTube video that I got this code from, if you want to look at it. You have to install a library called TSP. I imagine that stands for Traveling Salesman. And after I installed the library called TSP, and that worked, I was able to do this code in 6 lines of code after you install it. So that's 1, 2, 3, 4, 5. So let's see, 1, 2, 3, 4, 5. Well, maybe it's only 5 lines of code, but I think that the YouTube video said that you could do it in 6 lines of code, but excluding installing TSP, it only has 5 lines of code. So after you install the TSP, you have to import TSP. Then you have to make a matrix. So in this particular matrix, what I did was I created a 4x4 matrix. An R equals range len matrix. The shortest path equals, and they put it in a dictionary, I, j, matrix, I brackets, j brackets, for I in R, for j in R, and then you print TSP dot TSP, R shortest path, and then it gives you the shortest path is 74, and it's 0312, so that's your shortest path. The next, so that was a really good one, but you had to use a library called TSP to do it, and we did it in 5 lines of code, not including installing TSP. So now what we're going to do is we got another line of code, and this is the website that I got the code from, and so basically you can do the Traveling Salesman Problem in 10 lines of code. So let's see what he says. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So he did it in 10 lines of code. And I do have to say that I like this algorithm better than I like the algorithm using TSP. And the reason why is because it's using standard libraries that are supported by Python, and we don't know how long TSP is going to be supported, because I've heard about other libraries, other obscure libraries that are no longer being supported, and when they're no longer being supported, you can't really use them very much anymore. But what we're going to do in this code. We're going to import random, NumPy, math, copy, and matplotlib pyplot as PLT. Cities equals random dot sample, range 100 and a step of 2 for X in range 15. So you're going to say there's going to be 15 cities. And I counted them this morning, and it was 15 cities. And then it says tour equals random dot sample, range of 15, 15. It says for temperature in numpy dot log space 0, 5, num. I think that's 100,000. And then it's all of the rows except for the last one, I believe. I, j equals sorted random dot sample range 15, 2. New tour equals tour. So it goes to the colon I plus tour, j colon j plus 1 plus tour, I plus 1 colon j plus tour, I colon I plus 1 plus tour, j plus 1 colon. So obviously the person who did this is very good at maths and very good at thinking and very good at rationales. And then he asks the question, he says, if math exponent, and he gives a lot of words, a big question. And if it meets that criteria, then tour equals copy new tour. And then it says plot plt.plot cities, tour, I, and then it's like modulo 15, and it's like the first one for I in range 16, cities tour I modulo 15, 1, no, brackets 1 for I in range 16, and it says XB. And this is your outcome, and I actually counted all the little X's, and those X's represent cities, and it was 15. So they say that you can do it again to get a different outcome. So we'll do it again to try to get a different outcome. So we're just running the script at the moment to try to get a different plot. So it's plotting it, and you see that it gave you a different outcome this time. So it's very interesting. I mean, the person who wrote it obviously is very intelligent. He knows a lot about mathematics because he's used the math function. And so that's one of the reasons why I keep going over these videos and going over these algorithms, because I'm hoping that I'll absorb some of all of this intelligence, you know. And then the last one, the last algorithm I took from Geek from Geeks, and you can click onto that link to find it. And it said Python 3 program to implement Travelling Salesman. So it's using the naive approach from SYS, import max size, from idle tools, import permutations, V equals 4. Says, and then it says implementation of Travelling Salesman Problem. And so we're going to create a function here, def Travelling Salesman Problem graph, S. So we're going to store all vertex apart from source vertex. Vertex equals close empty brackets. For I in range V, and you know V equals 4. If I does not equals X, vertex append I. So and then what we're going to do is we're going to store the minimum weight Hamilton cycle. Min path equals max size. Next permutation equals permutations vertex. for I in next permutation. Then we're going to store the current path weight cost. Current path weight equals 0. Then we're going to compute the current path weight. K equals S. For J in I, current path weight equals current path weight plus graph K in brackets, J in brackets. K equals J. Current path weight equals current path weight plus graph K in brackets, S in brackets. So we're going to update the minimum. Min path equals min path current path weight, and we're going to return the min path. And then you have your driver code. So if name equals main, the matrix representation of the graph, so you're going to create the graph, and the graph is going to be a 4x4 matrix. S equals 0, and it says print Traveling Salesman Problem graph, S, and so the answer is 80. So that means that 80 is the shortest path that you can take. But I do have to say that the one I like the best is the middle one, because it actually gives you the route to take, whereas the top one, it gives you the shortest path, and then the bottom one, it gives you the shortest path, but it doesn't give you that much information about it. So that's it. That's it for our Traveling Salesman Problem. You've got 3 programs that you can use to find the Traveling Salesman problem, and I've given you the sources, the web pages that I got that information from. So that's good. So you can always look it up and read it yourself if you want to. So I'm going to conclude this presentation where I gave you the 3 solutions to the Traveling Salesman Problem, and I hope you like that. I would like to thank all of my subscribers for supporting my channel. If you like this video, please like, subscribe, and share, and I look forward to making more videos for you in the future.